All right, in this problem, I want to find the equivalent capacitance between points A and B, given the combination of capacitors shown below. At first, this might look like a very difficult problem, but if we really consider our understanding of how charge moves in conductors, it's actually not such a difficult problem at all. One of the principles that we can use is that every point inside a conductor here, where there are no circuit elements in between, is really all at the same electric potential. They would all be at the same voltage, okay? So the actual geometry doesn't matter so much. All right, so if we were to take the top path here and go through capacitor C1, we would be able to reach point B at that point. So what I'm going to do is redraw the circuit a little bit. And we'll do this. This is going to be point A and point B. And the capacitor C1 is right here. On the other hand, we could take the lower path here, go through the 6 microfarad capacitor, and also reach point B. So I'll redraw that part of the circuit. And it could look something like this. Our third option would be to travel through the middle branch, and we can arrive at point B that way as well. So interestingly, this circuit isn't quite as complicated as it seemed. The geometry of it made it look worse than it was. But it's basically 3 separate branches which are set up in parallel with each other. All right, so this would be C2. This is the 5 microfarad capacitor. We'd like to replace C1 and C2 with their capacitances. So I'm going to go ahead and do that now. All right, let's use the rule for series capacitors in order to simplify that middle branch. It will be C of the 5 and the 2 equals 1 over 5 plus 1 over 2. All right, that's 1.43 microfarads. So I'm going to redraw the circuit so that we have just one capacitor in that middle branch. And we'll have this. Now we see that these 3 capacitors are in parallel, so we'd like to combine them into one single capacitor. And we'll call that CEQ. The rule for CEQ here will be 9 microfarads plus 1.43 microfarads plus 6 microfarads. And we'll have 16.43 microfarads. And that will be our answer for the equivalent capacitance of this complex network of capacitors.